Okay, this 1-point observation here makes me believe this might have been from a test, but posting this video like 16 hours after the question was posted, so assuming the test is over, if it was a test. You can do this by the washer method. You could also do it with the shell method, but they're suggesting you do it with the washer method. So let's look at the graph. This red graph is the graph of y equals 1 over x cubed, or y equals x to the minus 3. And this blue region, we're revolving around this axis of revolution, y equals 1. So when you use the washer method, we want to calculate or come up with an expression for the outer radius, the distance from the axis of revolution up to the outermost portion of the region being rotated, and the inner radius, distance from the axis of revolution to the innermost portion of the region being rotated. So the outer radius is a dot y, the y coordinate at the top, minus c dot y, which this is really the point x comma x to the minus 3. And this is really the point x comma minus 1. So the outer radius is this y coordinate minus this y coordinate. And that's what this is right here. It's the outer radius squared. And your typical washers, when you're using the washer method, are perpendicular to the axis of revolution. That's why we have this dashed black line here. That's a typical washer. If I slide this point to the right, I could get another washer over here. But the formula is the same. Outer radius squared minus inner radius squared. The point is these washers are occurring from x equals 2 to x equals 6. That's why we have these limits right here. And here's the inner radius, y coordinate at the top, which is 0. This is the point x comma 0, minus a minus 1. That becomes 1 squared, or 1. So let's just take a look at how you might evaluate that. You got to square this binomial, which means square the first term, double the product of the two terms, square the second term. These two combine to 0. So we need an antiderivative for this. Raise the exponent by 1, becomes a minus 5. Multiply by the reciprocal of the new exponent, or divide by the new exponent. This exponent becomes a negative 2 if you raise it by 1. 2 divided by negative 2 is negative 1. So that's really negative 1 over 5 x to the 5th minus 1 over x squared, evaluated from 2 to 6. So we're actually raising 6 to the 5th power, multiplying by 5, minus raising 6 to the 2nd power. And then we're subtracting, put the 2 in for the x, okay? And it looks like you get this mess right here. So if I multiply that by pi, I'll have the volume of the solid of revolution. There you go. Hope that helped. If you have any questions, post a comment.